Hello everyone, welcome back to episode 2 of our Architect a Storage Server video series, where we do a little bit of whiteboard, we do a little bit of lab building, and we just do a real life kind of scenario and talk about all the details. So you're joined by familiar faces. You've got me, Brett, and Mitch Hall over here, and today we're going to talk about Ceph again.
Brett, buddy.
What?
All we do is talk about Ceph.
No, we don't.
Are you sure about that?
Well, everything more about Ceph. We've talked about this already, but Ceph clustering, we love Ceph. For those who have mounted a ZFS share before, what are my options for tools to deploy a Ceph cluster? It is called Ceph GeoRep. This week, I am talking about Ceph iSCSI Ceph clusters. I guess so. What do you want to talk about?
Well, I think it's time to give a little bit of love at ZFS. We haven't really talked about it very much. It's a big part of our business. I'm a big fan of ZFS. I don't know about you.
Sold.
All right.
We're doing a ZFS one. Okay, so we're going to do a ZFS architecture video, and Mitch, you got your wish. What are we talking about today?
Oh God, you put me on the spot here. Okay, so, through the run of a day as an architect here, I talk to businesses all the time, big, small, medium-sized, and for the smaller and the medium-sized businesses, what I'll see a lot of times is they have a lot of storage needs. You know, they have a need for virtual machines. They might have a need for even a database or two, as well as file storage, right? Everyone needs file shares as well.
You need a little bit of everything these days.
A little bit of everything. But they may not have a budget to have a dedicated SAN for their VMs and a dedicated high performance
tier. Yeah, the more legacy way of thinking anyway. You have a box that does one thing and just that
and just does it. So, I mean, ZFS is a really unique architecture and that comes with a lot of really cool tools. And I think what we can do today is really show off the way that you can leverage everything that ZFS has to offer to really make a compelling solution that can do all of those things.
Okay, so we're going to architect a single server ZFS file database VM store.
Exactly. Yep.
Okay, well, here, I'm going to give you some rules.
Okay, let's get to the rules.
All right, so this thing's got to be like, here, I'll just give this a little, let's just call it workload.
Okay.
Sorry, guys, I have the handwriting of a doctor, but...
And before we even start, I want to preface this by saying that in no way am I going to say that a dedicated ZFS box, even if we take all the tricks and everything that ZFS gives us, is it not going to be better than a dedicated high-performance SAN, a dedicated file server, a dedicated storage for your database. But what this will do is give you something that is fantastic at serving everything on a good budget.
And it'll be good enough for most people.
Absolutely.
It's really what you're getting.
Yeah, exactly.
You don't need... Yeah, okay, I see what you're saying. Yeah.
All right.
Okay, so this thing is going to have some DB storage. Let's say you're going to want to store about 10 terabytes on there.
Sure.
What's 64?
64 kilobyte record size. It's a common one.
We'll tune for that.
We can always tune for other record sizes as well, but we'll have to have a target that we want to hit. So let's do that.
I was going to write this small, and I didn't.
All
so
good.
then we're going to have some VM store here.
VM storage. So I'm thinking like infrastructure, right? People need to store their DNS server, their Active Directory, potentially a mail server, things like that.
5 to 10. So we're not
10.
actually putting like major data here. It's literally the operating system data. Anything else we can put on the...
Yep.
Okay, cool. Nothing special there. And the rest, let's just do some good old general file sharing.
Yeah.
Where we do some SMB, NFS.
Yeah.
So just general storage for everyone. And we'll just use the rest of the space. Okay.
And as a general rule, your virtual machine infrastructure is going to be more I/O intensive or random I/O intensive than say a file share, which may be more streaming reads and writes. And so this is why we're kind of defining all these to make sure that we have a Z pool that can handle all of these simultaneously on the same pool.
Yeah, because you'll get into it, but like this is one of the coolest parts of ZFS, how you can segment certain parts of the pool and tune accordingly.
Exactly. You got it.
Okay, so one other rule that you have. Oh, I literally just crossed that out. Whatever.
Yep.
We'll keep that on the board so you get something to reference.
Okay.
But
Oh, we're back to the squares again, are we?
Oh, it's a rectangle.
Well, yeah, true enough.
And
I failed miserably.
it doesn't look like a trapezoid / parallelogram or whatever you drew last time.
Yep.
No, I'm sorry, I'm being mean. No, I already got some hardware in the lab for you.
Okay.
We have our Q30H16. So
Okay.
what that means is there's the Mobo chamber. You've got 15 hard drives available to you. You get 7 hard drives in this row, and the rest is 16 SSDs.
Okay.
And then up here, I have a single NVMe for you. Just one big 1.9 terabyte version.
I can work with that. And that's actually great because, in a traditional Z pool, you would imagine there's not really any good way without taking advantage of everything ZFS has to offer to build a pool that uses all of these in just regular Vdevs. So we're going to have to really kind of know what we're doing with ZFS to make use of all of these in a single Z pool.
Which reminds me too, because you said the magic word Vdev. Disclaimer out to everyone.
Yes.
We're going to dive right into some ZFS terms. This isn't really a ZFS 101. We have a lot of stuff, whether it's videos. Actually, the latest blog we put out is a great primer on all the ZFS terminology and what that means to traditional RAID stuff, and just more of how it breaks the mold.
Yeah.
So for any newcomers, and if you say we're newcomers to ZFS and we say in words you might not understand, go check out some of that material and come on back.
Yeah, that is a great point because we're not going to spend the time, everything we talk about, we're not going to break down what it is. We'll break down the important bits, but yeah, definitely reach out check out our other content that we have for sure.
Reach out too if you want.
Yeah.
Anyway, we'll leave this up, but I'll get rid of this picture.
Cool.
And so that's the hardware you got. We won't talk network here. Let's just say it's 10 gig.
Yeah, 10
it's
gig.
just 10 gig. We don't have to get into any fancy stuff there.
Got it.
I'll turn the macro over to you, and
We'll get started.
we'll just what are we building?
Well, I think what we're going to do is the vast majority of our storage is going to be the file sharing, right? So I think that's where our Vdevs are first going to be kind of what we're going to focus on at first. And so with a file sharing or any solution really, while RAIDZ1 is always an option, it's not an option that we'd ever really recommend for production.
Z1, just one parity.
One
RAID
parity,
5,
one drive of parity, right? You lose that drive, you're essentially the pucker factor kicks in, and you're
heard that one before. I like that.
You're waiting for that drive to resilver, and if it doesn't, well, you have some data loss. So we're gonna definitely build on a RAIDZ2. So let's go with.
I won't make fun of yours.
No, this is big.
That's
So
good, buddy.
2 Vdevs. So a Vdev is like a RAID group, right?
Yep.
Not specifically striped, but it's taking 2 RAIDZ2s and putting them together. So let's say we've got, is that 8? Nope. There we go.
There we go.
So we'll do RAID groups of 8
Yeah, and
for our spinning storage.
Just for everyone, I gave you that hybrid earlier, but we're talking spinning storage. We have 15, and then we got 7. We have 22 hard drives available to us.
So,
right? 15 plus 7 is 22. Good.
So it'd be not, yeah. So with the 8 RAID group, I guess it doesn't really work. But let's just say we only need 16 for now. So let's do the same thing. We'll have 8 drives.
Oh, okay. We're only going to utilize.
Yeah,
16
we'll use 16
now.
drives for now, just to kind of make this work.
Okay.
All right. So you've got 2 drives of parity in each one, so you can lose 2 disks from either RAID group. Obviously, if you lose more than 2 from a single one, you're in trouble. But that's why you stay on top of your failures and rebuild and resilver when you have to.
Okay.
Okay, so that's going to take care of this, right? It's going to take care of our file sharing. We're going to have, and this is, I guess we'll call this our ARC level, adaptive replacement cache. This is what we're going to have to read back out to our clients. And we'll also even call this our RAM as well, because what I want to show off here is a lot of our file sharing data is going to be what we call asynchronous writes. And what asynchronous writes are is they come from the client, they come into the memory, they get written here. As soon as they get written here, they get acknowledged back to that client. So they go right back without ever committing into the disk long term.
Okay.
So ZFS uses something called transaction groups. So every 5 seconds, what ZFS will do is it will flush these transaction groups back to the long-term storage.
Mm-hmm.
Make sense?
So
Okay.
it's kind of like a write back cache in a way.
Yeah, it really is. And Seth, here we go, we're talking Seth already. ZFS does atomic writes. So if any of these writes that it's doing is actually changing data that already exists, it unlinks the old block and links the new one in one single transaction, so you don't end up with data corruption or anything like that.
Copy on write.
Copy on write, you got it. Now there's another part here that's built into a Z pool by default called a ZIL, ZFS intent log. And for anyone that really understands ZFS, I'm not drawing to spec, like this isn't what it actually looks like, but it really helps you visualize. So a ZFS intent log, what that is for sync writes. So if we have async there, we've got sync here. So sync writes can be anything, well, it really depends. Whatever the client, if the client write has a sync flag, well, it's gonna go sync. So things like virtual machines, by default, are gonna be sync writes. Databases are gonna be sync writes. These are writes that you wanna make sure commits to your long-term storage before sending that acknowledgement back out, right? Because you wanna make sure that that's there on disk before it sends it back to your client. So you can think of, like, let's say if you're a business and you do transactions with money every day, some of those transactions you want to make sure they're committed there and you have that on file before it goes back out, because if the server fails or if power goes out, things like that. Okay, so sync writes are going to be the VM and the DB. So this type of solution right here, what would happen is the write comes into the client. It's going to go to the ARC as normal because it still uses those transaction routes, so it comes in. But it also, at the exact same time, goes to the ZIL. And it writes there as well. And
It's intent.
it's intent of what it's going to eventually write. And so as soon as it gets hit there and gets committed, it immediately goes back out to the client. Now, eventually, the transaction group flushes and it gets written to disk as normal. But this is to make sure that if power ever did go out, and when you come back on, you could reread this ZIL and say, we were going to write block A, B, C, etc.
And this is one of the things that makes ZFS really unique compared to other file systems.
Absolutely.
Is that it's atomic in its way, that it is ACID compliant, I think is the database
exactly.
word, right?
Yep.
And it's that idea that it needs to guarantee, it functions more as a database than a streaming.
And that's what it is.
Yeah, cool. And this ZIL is always present.
Always present.
It has to be there.
It has to be there, exactly.
So by default, it lives on the spinners?
Exactly. And so what you're getting there is you're competing I/O, right? Because your sync write going into RAM and it's getting committed here, but it's also being written here.
And it's gotta do this first.
It does that first, exactly.
So you're telling me that it wants to do a small, somewhat random database transaction on spinners before it can write its write.
Before it can actually write the
that's
final
gonna be
write.
slow.
Exactly. There is evidence of the ZFS intent log being able to do like write it once and then instead of committing it, doing pointers. But every research that I've come up against is that that's a really bad idea because it makes every write in your ZIL essentially a random write. So it's not a good idea. So what we talked about here is the way it works.
So there's a way to move this ZIL. We said it's on the disk by default, but we can put it somewhere else, right?
Exactly. And that's how we're going to make use of these extra SSDs and these NVMEs that we have.
Okay.
Okay, so like we touched on, right? The file sharing on its own would have done great with that, but now we throw these in the mix and you've got everything competing for the same disks. So what we can now do is we can say we want a slog device, all these funny terms, right? If you're not familiar with ZFS. So what we can do is we can create a new Vdev in our system called a slog. And what that is a separate ZFS intent log. So typically we like to mirror that, right? So
yeah, because you don't want to lose it, right?
You don't
Because
want to
if it dies, that's the whole point.
Yeah, that's a few seconds of dirty data that you're going to lose. Or sorry, that's clean data.
But it doesn't have to be very big, right?
No, actually very, very small, because at the worst it's like 20, 30 seconds of data that is ever going to stay on there. It's always transactions.
So rule of thumb should be then like whatever your like max network bandwidth is.
Yes.
Times 30 seconds.
Exactly, you got
size for that.
Yep.
Because it can't ever ingest more.
It can't ever ingest more than what it can do over that many seconds. You got it exactly.
Okay.
Actually, wasn't going to bring that up, so thank you. So what I've got here is a new Vdev, and while it is part of this pool, I'm just making it separate so we can kind of show off.
Is this the slog you're showing us here?
Yes, exactly.
Okay, we're doing slog. Okay.
So this is slog.
So in that case, we can
And
pretty much erase that.
You got it. I can do that for you. So
But I like dirty. I want to use my finger.
Right. And so now what you can see is when that sync write is coming in, rather than having to come in here and compete with the rest of the I/O, it goes to these, and I'll mind you, much faster SSDs than the spinning storage. As soon as it gets here, it can commit that back to the client and say, hey, I've committed that. You're good to go. Keep feeding me data. So now this is unburdened and can still do this. And this is doing just a dedicated function of handling your VMs and your database.
So the ZIL's living on these now, right?
Yes.
You drew 4. We really only need 2.
You don't really only need 2. I was like,
you just want to show me how good you can draw squares, rectangles.
Yeah, exactly. We've got like, I think 8 of them in there, so I was like, hey, I'll just take 4 of them.
Okay.
But yeah, 2 is good. If you want to double them up and do 2 mirrors, you can. But yeah, so we got 4 SSDs. Okay, so that's great. That is going to help your VMs. Any writes in your VMs is going to help. We talked a little bit about the ARC, but I'm going to explain a little more. So where the ARC is an adapter replacement cache. So every file system has a caching mechanism of some kind. Most of them, or all of them that I know, use the actual operating system cache, like the page cache of the OS. ZFS is very different, where it can take a whole lot of your RAM or your memory and use it as a much better type of cache. So it's not the OS cache, it has its own. It's called the ARC.
Yeah, the OS cache is optimized for being a good general purpose
Purpose, you got it.
The ARC is optimized for storage systems.
Just for storage system, just for ZFS.
Gotcha.
So what it has is it has the least recently used, like the regular page cache, where the oldest stuff gets pushed out. But what it also has is data that gets read more often gets a higher weight in your ARC. So if you have some VMs that get read very, very often, you're going to see that a lot of that is going to sit in your high performance ARC, and you're going to get some great performance.
ZFS has some cool tools for like seeing
tuning
the ARC
that
summary,
and seeing
right?
that and seeing, yeah, exactly, seeing like how often your ARC is being hit. And if it's very low, well, then you can do some tuning.
Because that's the hard part about cache. It's hard to know if you're using it.
Very,
or not.
very much so.
So yeah,
Yeah.
ZFS makes that easy.
Yeah, they very much do. Okay, so that covers, like I said, that's going to help with both of these. The ARC is going to help with all of them. And then the last one that we want to talk about, and it's actually not talked about very often from what I see.
Well, it's a relatively new feature.
It is quite new, yeah, is the special Vdev. And the special Vdev's main purpose is to offload the metadata of your file system onto a new Vdev. So by default, ZFS will hold a lot of your active metadata in this memory pool. So a lot of your metadata will stay here. But again, it can't hold everything, and there's going to be some that it has to go back to disk for. So let's just call that your metadata. Oh, gosh.
No one's reading that.
No one's reading
Just
that.
scribble that.
Metadata.
No one's reading that.
Yeah.
Metadata.
Okay. So what we can now do with our NVMEs that we have left over, and I'm going to just remove that for a second, is build one more Vdev, and this time we're going to do 2. We only have 1 in our system down in the lab, but that's just because that's all we had. You're going to want to mirror this up as well because it is very important. And more than anything, maybe even potentially a 3-way mirror, because if you ever lose your metadata, your file system, everything is gone then, right? So you may even want to do like a triple mirror.
Okay, but we're going to play fast and loose today.
Yeah, just for today.
One.
Just for today.
Yeah.
Yeah. So what this does is, like I said, it's special because it's the special Vdev. And so all of your metadata now is being removed off of this, and in a file system.
When you say this, you mean like the spinning,
the spinning storage, the
yeah,
actual regular Vdevs, the RAIDZ2 Vdevs.
Yeah.
Now in a file system, you can think file names, the size of the files, the permission bits, all that stuff are reads and writes that your array has to do alongside the actual file data itself.
And they're very small.
Very, very small, exactly. And so with spinning storage, which isn't fantastic at small reads and writes, that can bog that down. Like I've heard terms of like up to 50% of your file system workload is metadata, and that's very, very possible.
So like, just for those, it's like when you would be searching metadata, it's like literally if you got this thing through a SMB share, you go to File Explorer and you search a file.
Yes.
And it's doing the spin as it loads. It's because it's a metadata workload and it's reading it all off the disk.
You got it.
So what you're telling me here is where we move that over to the fast special device, you should just be able to see
much faster.
So then the spinners can do its job, serves the
things.
data, and let the fast things do the...
Exactly, and that's really where it's fantastic, right? You're letting your HDDs do what they do best, and you're letting other things do things better.
Sorry.
Okay. And so, yeah, like you said, the search, or even like an LS of a directory, it's just so fast.
Yeah.
Okay, and then the one last thing I want to talk about the special Vdev too is the fact that you can also do a small block workload on there. And what I mean by that is in our Z pool for our data sets, we may use different record sizes for different use cases. So in the case of our DB workload, we would definitely want to match our ZFS dataset record size to our 64K record size of the database. Matching block sizes really helps performance. But what you can do is, so let's say you have a 64K record size for a data set or a 128K for file sharing. What you can do is you can set smaller blocks. So let's just say in the case of this, we want to do 32.
That's a 2.
That's a 2. 32K
Yep.
block sizes and smaller. Instead of going here and being written here, it goes directly to the special Vdev. So,
Okay, cool.
so what that really comes with is you end up with kind of a hybrid tier at that point, right?
Yeah.
Any small writes bypass your HDD and be written to your NVMe high performance storage.
And with all that said, we still have the ARC cache and everything it
Exactly.
can too.
Yeah, you
So
got
we
it.
got tiers on tiers.
We got tiers everywhere, and safe tiers at that, because you know what I mean. Many times when you start putting all these caching mechanisms in place, it's kind of sketchy, right?
Yeah.
But because we're playing in ZFS rule set, we're actually doing something that's very, very safe. And
Everything's ACID compliant. Everything goes through
Yep.
this slog. And
Yes.
that's right. Oh, that's cool.
you got it, and everything is transaction and atomic, and so we're not, deleting a block before we write another one. Everything happens at the same time, so there's very, very low risk of corruption and things like that.
Fantastic.
Yeah, so I think that right there gives us a fantastic single server with, doesn't break the bank, right? Because you're only using, in comparison to the rest, very small amounts of flash compared to your spinners.
Mm-hmm.
And you're getting a really good balanced CFS array.
Cool. And when we're going to have a data set for each of these use cases, right?
Yeah, absolutely.
Okay, so we'll get into like what parameters and stuff we want to change and how we're going to cut that up when we get out in the lab.
Yeah, I think so. People may be surprised because for the VMs, they may expect that, like if we're going iSCSI, we may be using zvols. Many times we'll actually just use a data set and use a file IO over iSCSI. If we're using Proxmox as the onboard ZFS array, that will use zvols, but I think for us, because we're using iSCSI, we'll be using file IO. But yeah, we'll show that stuff off once we get in the lab.
Okay, sounds good.
All right.
So that's a good whiteboard part. Yeah, like you said.
It may not be as clean as yours.
I don't know, man. The last time we did this, we had squares that look like circles.
Yeah,
So
sure enough.
we're getting ahead.
We're getting a little better. Yep.
Yeah, so we're going to take our Q30, our H16, we're going to build 2 Vdevs of RAIDZ2 on the thing.
Yep.
We're going to use the SATA SSDs in it as our slog devices.
Yep.
And we're going to use our NVMe as the special.
Perfect. Yep.
And then we'll hook it into everything.
Sounds good to me.
Let's go to the lab.
Let's go to the lab.
All right, so here we are. We're back in the lab. Don't mind the echo.
We'll get one chirp at least from
We've
the
got high
audience.
ceilings. It's a nice spot.
Yep.
We like our echo. No, we're not here to talk about that. We're here to finish our architecture video. So we're going to take all the good stuff that we talked about in the other room that we drew up, and we're going to do it on our Q30 H16 here. Sorry, Mitch, I pushed you out of frame a little bit.
All good?
But let's take a close-up look at this thing.
Yeah, come on in.
First of all, I want to say I tricked all you guys. This is a Ceph video.
Oh, you've
This
got to
is
be
one of my
kidding me,
Ceph
Brett.
nodes I pulled apart, so you can never quite get away from that.
Follows us
but no,
everywhere.
Let's take a look. So what are we working with here, Mitch?
All right, so we got our 16 drives that we talked about, 16 HDD drives, that is. Since this is a hybrid 16, we've got our 4 SSDs. We've got lots of room available for expansion on both sides. And then also we've got our NVMe. So this is our NVMe carrier card. This can fit up to 4 NVMEs on there. So yeah,
Cool.
that's about the long and short of it.
Which I was thinking, after we finished that first part, like, sizing things are relatively easy, but I was thinking about it. If we are going to put small metadata or small block reads or
Yep.
writes, or geez, I'm screwing that up,
Right,
but like
yep.
the small part of it that we can serve from the special Vdev,
Yep.
it's kind of variable on how heavy your workload is for how
how often
much
you're
of that
writing.
data. Yeah.
Yeah.
So I guess what I'm saying is sizing that special Vdev could get difficult.
Could get a little difficult, and that is very true. There's a few things that ZFS does to combat though. One is, if you set that, let's say that ZFS small block size to 32K,
Yeah.
and all your 32K writes will go there until it hits to about 15% left of space.
Oh, so 85. Yeah.
85%. ZFS will be like, okay, you're pretty full, and it'll start moving those back to your spinning disks to reserve that last space for your metadata.
Gotcha.
But you're
some people
totally
don't
right.
even know how much space in general they're going to
Exactly,
use,
let alone
how much
third
of it
block
will be
size.
metadata.
Yep.
So that's nice protection mechanism.
It is great
Because I
protection.
guess that's the flexibility of this. We are showing this to show spinners, SATA SSDs, and NVMe, but we
Yep.
could very well populate this whole thing, have a huge special Vdev too.
Absolutely, yeah. Rather than being limited by these 4, we could have many more.
We're flexible.
Yeah.
All right, so let's quick tour of the hardware. This is our beautiful hybrid unit.
Yep.
Let's jump to Houston and build the thing.
Let's do it.
Okay, cool. All right. So this is our landing page. I
Yep.
think most people have probably seen this before. So let's hop right into the ZFS tab. So no pools have been found. Makes sense because they're not there.
Yep. So I guess the starting point is creating those RAIDZ2 Vdevs.
I'm laughing at my comment of there's no pool there because it's not there.
It's not there because it's not there.
It's like that. You can tell this is a birch tree because the way it is. You
I
ever
have
see that
no
nature
idea.
video?
No.
Oh no. Okay,
No.
well we're watching.
We'll find that
after.
later, yeah.
So what are we calling this thing?
God, I don't
Storage. I've
know.
decided.
Sure, that makes sense.
Okay.
It is storage. All right.
So this is
RAIDZ2, like we
RAIDZ2,
talked
that's
about.
what we want,
Yep.
correct? And the way this works is we add one Vdev at a time. So we're going to create a Z
That's
pool
right.
with one Vdev, and then we'll add the second one
Exactly,
after. Then we'll
yeah.
add the slug. Then we'll add the
You
special
got
device.
it. We don't want to add all 16 at once, or it'll just show up as a single big old Vdev.
Cool.
And that's not good. And for anyone that doesn't really know our UI, this is really cool because we have our device aliasing that gives us the actual ID right to the actual slot number. And we'll probably show more of that with our disks later. I
Yes,
guess,
yes, exactly. So when you make this pool, you got to address the disk. There's multiple ways to do it. You
Yep.
can do it by its regular old SD name, but everyone knows it's not best because it will change.
Change on reboot. That's
yeah.
right.
And the other thing is, where is dev STC? I don't know.
Yeah, I don't know either.
So device alias is a way that we can address disks
By their slot.
Yeah. Anyway, I just repeated what you already said, but
Hey, you hit it home.
okay.
There we go.
Okay, so we'll make our first Vdev. So we want to add how many to this?
8 of them.
Okay. So 1 1, 1 2, 1 3, 1 4, 1 5, 1 6, 1 7, and 1 8.
There we go.
Okay. Sector size, the default 4K, that's
yep.
normal. So that is the sector size of the underlying disks.
That's
These
right.
are advanced format disks, 4K.
Record size. So this is the cool one. I wanted to mention this in the whiteboard part, but quickly I'll just talk about it. ZFS chose the 128K record size as the default record size. For the reason of it's not particularly amazing for any workload, but it's also not terrible for any workload either.
the jack of all
It's the
trades.
nice jack of all trades. So we'll leave our pool at that, but we're definitely going to want to play with that on our data sets.
So when we cut data sets, like I can choose different record size.
You got it, absolutely.
And that's why ZFS is good for mixed workloads.
Big
Because
time.
you don't have to have one storage pool that works one way.
Exactly. You can change that as needed for different data sets.
Gotcha. Dedupe?
No, let's not do that.
Okay.
So reservation, yep, let's just pull that down for now.
Yeah, we just want to use all the space we have.
Yep, LZ4,
You
that's
get
always
compression
great.
for free.
Pretty much
Actually-
for free, yep.
Actually, with ZFS, you end up getting a little more.
Better performance sometimes, yeah, absolutely.
I know, it's crazy. I don't want to automatically expand right
No.
now. Automatic trim, I don't have any SSDs, so
No.
that's fine. And we'll leave the rest of it for now.
Yep.
Forcefully create pool, we don't need to do that. That can be useful if you're doing things you necessarily maybe shouldn't.
Should be doing, yeah, different drive sizes or something.
No one does that here. We always follow the rules.
Yes.
Always. All right, so let's spin for a minute as it does. Okay, and there we go. We got a pool. Anyone who's used to other RAID that's not ZFS,
Yep.
Either that's software RAID with MD RAID or hardware RAID,
Or, yeah.
when you make your pool, and you go home and come back 2 days later
Exactly,
when it's done syncing.
yeah.
ZFS, because of copy on write, does not do that.
No sync time, yeah.
So it instantly is ready to go.
It's actually funny because a lot of customers that have used RAIDs in the past and come to us, they're ready for that big 2-day or 1-day sync time, and we're like, no, you can start using this
They
right
already
away.
told their boss, this is going to take me 3 days,
exactly.
man.
Right, yeah.
Sorry.
All right, so we're good.
Okay,
We
so
got
now
our
we have
first
storage
Vdev.
pool.
Yep.
So what are we working with here? We have 58.22 terabytes available to us.
There we go.
Cool. Oh, didn't want to shrink that. So what did we do? We wanted to say we were going to do about 10 terabytes for the DB, about 5 to 10, and then everything else. So
And then,
that seems about right. So we
Yeah.
got about 20 something terabytes for our file share. Yeah,
And we're going to double this up
that'll
here in a
work.
second.
That'll work.
Yep.
So it's mounted, no replication, we're not doing anything. So what's the next steps here?
Next step, let's add our second Vdev in.
Oh, thank you. I forgot all about that. That's why we're missing
That's
half our
why we're
space.
missing half the space,
I was questioning that a little bit. But you know, the show must go on. Okay, so what we'll do over here is we're on files. We'll jump over to the status tab.
Yep, that's right. We'll go to
So
our Z
here's
pool.
the pool we made in storage and our first Vdev, which is just RAIDZ2, and then
The first 0 is the first Vdev.
exactly.
So our next one will be
one through to
RAIDZ2 1.
Yeah.
Yep.
Okay.
All right.
Next, we're gonna go, not configure, sorry, we're
I
gonna
think
go
it's
to
there,
the top
yeah,
level,
yeah,
yeah.
there you
We're
go.
gonna add a virtual device. Same thing again, careful, it defaults to mirror. We don't wanna do that. We want to do a Z2.
You got it.
So I'm gonna pick 1.9, 110, 111, 112, 113, 14, 15, and then we're gonna jump all the way over to 217.
You got it.
Yeah. Same idea, you can forcibly add it if you want. If you're adding things of the wrong size, again, probably shouldn't be checking that unless you're
Nope.
hacking around
Testing
and
or playing
fun.
around,
Yep.
yep. Okay, now we got our storage.
Okay, cool. So we'll go back to file systems. We'll take a look at that. So now we got our 116 terabytes. Okay,
Yep.
that seems a little more what I was expecting.
That's much better.
Okay, so we're not done on Vdevs yet, though, are we?
No, we're definitely not.
All we did was added our.
We added our data Vdevs, I guess you could call them. Now we're gonna add our support Vdevs.
Gotcha. So same thing again. We're going to go to the top level
Same
Z
idea.
pool.
Yep.
We're going to add a virtual device.
This time we add our log.
So we're doing slog this time.
Yep.
It's called log in here, slog, zil. You'll hear you'll hear different things,
Yeah.
but slog and log is
Yep.
usually what we're talking about
You
here.
got
right?
it.
We want to click mirror because
Yes.
it wants to mirror the disks.
Yepers.
Still device alias.
So we got 4 SSDs, so we might as well throw 4 of them on there.
Okay, sounds good.
Yep.
I won't make a comment about forcing it this time. But I guess I just did, so sorry.
All right, that was quick.
That was quick, so now we've got our logs, our mirror, great. What's next? We need another Vdev,
So
right?
our last Vdev, we're gonna go and get our special Vdev now on
Okay.
our NVMe.
So again, we're going to add our virtual device.
Yep,
We're going to jump right to special.
yep.
Typically, in real life, you should mirror this.
Yes.
We only have one installed, so we're not going to mirror it.
Yeah, real world, we would be mirroring it. Oh no.
And it couldn't. Let's check logs why I can't do that. I'll do it again while this is up.
Yep,
It's not a video if something didn't fail, right?
that's right. Just like the demos that I do every week, you practice and nothing will ever go exactly to plan. It may actually require you to force if you're only adding one, but I'm not sure on that. Yes, it does actually. Now I'm remembering that, because when I do it in the command line with a single, it will require you to force it because it doesn't want you to be doing just a single, but we don't want to mirror either. We don't have enough.
So I should have made a comment.
You should have made the force.
Nah,
Well, okay,
still
but now it's
doing
not
it
going.
now. All right,
We can add it from the command line, but I guess, yeah, that's a weird one.
that is weird. I could just keep beating my head against the wall here, or we could just do it from the command line.
Yeah, let's try from the
Let's
command
do it from the command line.
All right, so,
So we're gonna
Z
go
pool,
Z-pool.
add,
Storage.
Yep.
Is it just special?
yep,
Dev.
NVMe 0N1.
It's very possible there's something on this.
Yeah,
thing right now.
dash F. You're gonna, yep, so you need the dash F.
Mismatch replication pool uses RAIDZ and new Vdev as a Z.
Yep,
Yeah.
which is fine.
Yeah.
There, okay, so for some reason the UI doesn't like it unless you have a mirror, which, I mean, there's not gonna be
Good.
any real, yeah, exactly, good.
Yeah.
There's not gonna be any real workload where you really wanna do that.
Anyway, show must
Cool.
go on.
So now
we
we've
will
got
not
our-
edit that out.
No, we won't. All right, so there you go. So it looks like the ZFS tab really wants you to do it right,
Yeah.
which is what we'd expect, right? But we kind of fudge it just to get through the video because we only have one NVMe here. But we can now see we have our log,
Cool.
we have our special. Let's make sure that shows up in ZFS though.
Okay, cool. So let's go to status here. And
RAIDZ1, RAIDZ2,
special,
sorry,
there it
RAIDZ2.
is.
Yep, there we go. There's our log, there's our special.
Okay,
All right,
everyone's happy.
so our Z pool's ready.
Mm-hmm.
Now what do we got? We've got to create our data sets for one for our database,
Okay.
and then one for our file share.
Let's do the database first then. So
Yep.
we'll just simply call it DB.
Sounds great.
Easy peasy.
Access time, that's usually one that you can turn off to save some performance.
That's just one less IO you have to do.
Exactly. It's just, and we already have modify time. We have all these other ones that are enabled. So,
So we'll let it do everything else.
yep, everything. The only thing we want to change is the record size to
Okay.
match our database. So we don't want to inherit that. That's really cool too. We'll get to that, the special blocks.
So we said 64K?
Yes, we did.
Okay.
Yep.
So and then the idea again here is your storage pool, your data sets can be variable, right?
Exactly.
Yeah.
Yep.
All right, we'll hit create then.
There we go.
Boom, file system created. DB.
We got our DB, and that's where our DB is going to write to. So now let's create our file server or our file share.
Okay.
So really it is going to depend on what you're using your file server for, but most business file servers, it's a lot of documents, it's a lot of smaller files. So you could go with a smaller than a 128K record size, but at the same time, if you also have big videos and big files, you want those to be good as well. So I think the 128K record size is a very sane one to pick for a mixed workload file server.
Great. Access time.
Yeah, we could pull that off as well.
Okay.
And again, we want to keep our compression and all that because it's nice, free, save space and free performance.
Cool, so I'm going to make it then.
There
Do
we
we
go.
want to put a quote on anything? Yeah, you know what? Let's go back and put a quote
Yeah,
on
let's
the
do
DB.
that. Let's set a quote on our database.
Oh, edit permissions, wrong button. I want to go configure file system.
Yep.
Put a quota. We
10
said
10
10
Yes. There we go. All right, so the way it stands, our metadata is going to our special Vdev, our sync rates are going to our slog. The only thing left that we talked about that we didn't set up, and it's something that you have to do from the command line, is to set those small blocks. Oh,
VMs.
did I forget one? Oh, and VMs, of course, yes.
VM storage. We'll just call it VM.
Yep.
Simple. What do you want to do record size here?
So if we're using ZVols, it'll have its own record size. For these ones, yeah, the 128K is fine for now, but if we've got some small I/O, we may want to have separate data sets for separate VMs. So like if we've got some small I/O, we'll go all the way down to like 16 or 32K for our record size.
All right,
So let's do that.
32 then.
Yep, perfect.
Create.
There we go.
Okay, now I cut you off on the fun part.
There we go.
Small block size.
Small block size, exactly. So where we can also use that special Vdev for not only metadata, but also any small block writes. So you kind of touched on the fact that doing that, you got to make sure that you have enough storage in your special Vdev to handle all those small blocks. It is great. There is a fail-safe in place that the special Vdev will say, hey, I'm 85% full. I'm putting these small blocks back onto your spinners. So let's go in and let's set the small block size for our file share. And
So are we going to do that for every data set?
no, I think for right off the hop, we'll just do it for the file share.
Okay,
but
cool.
you can set that as needed.
True, because the database and all that, like
That's using the 64K record sizes
Gotcha.
already.
Yeah. So we're going to configure file system.
Actually, I'm pretty sure this one you have to. Oh, yeah, we already said that. We found it here.
Yeah.
That's really cool. I didn't even know this was in there.
Yeah.
So now we can
You
set.
just love the command
yeah,
line so much.
I know I do.
Right.
All right, so let's say we want 32 and smaller in our file share. We really want that to go to our special Vdev.
Okay, and we're putting no quote on that. That's
No,
fine.
that's right. There we go.
Just to be complete, we said we were going to put a quote on this too.
Yes. Yep.
I'll just say 10 terabytes for that as well.
That makes sense. All right. So we have literally just set up an incredible mixed use Z pool that can do a lot of things really, really well just by making use of what ZFS has to offer in its architecture or if it's in its programming.
Mm-hmm. So from here, we would hook this storage into the DB.
Exactly.
We probably like maybe want to run the DB right anyway. Cool.
Yep.
File sharing would go over the file
go over
sharing tab,
SMB.
and we'd hook SMB or NFS
Yep.
or a combo of
So
both.
SMB and SMB by default will do async. NFS will do sync, but you can enable async, so you don't have to use that ZIL.
Most people where we're using this kind of as like a general storage share will use
Async.
Yeah, and they'll use SMB.
Yeah, SMB exactly.
VM storage, we can hook that into Proxmox.
We hook that into Proxmox via iSCSI. You got it.
Okay. One other thing I just want to cover real too is like, okay, you've got all this data and it's running, and you're worried. Well, our RAID's safe, everything's pretty good, but you know, disasters happen.
Yes, they do.
You just go buy another one of these, stick it somewhere else, and you see this replication tab here.
ZFS send and receive,
You
baby.
can go and configure a replication task.
That is really
so
cool.
what you would do is just point it to the IP and data set of that other box,
Yep.
and you'll get a full copy of everything you see here on the other one.
So this isn't like a file-based copy, right? Like this is a real.
It's block.
Yeah.
We use ZFS send and receive. It streams that across, and it's intelligent, as in it doesn't send the same stuff over and over again. It
Exactly.
only does change. Incremental.
Incremental,
That's
yep.
the word I'm looking
And it's
for.
not like an rsync where you have to crawl the file system every time. It just essentially knows what has changed. Wonderful. Very cool.
So this box is ready to consume storage. I
Yeah.
think we should call it here.
Yeah, I think we can call it here. Obviously, if anyone else wants to see anything more in depth of hooking some of these things into the end use case, let us know. We can absolutely go a little further for you, but I think everything we've done here was a really good job, and we can call it.
Cool.
All right.
So this is a good covering of the flexibility of ZFS, our Q30H16, and well, let us know what you want to see next.
Thanks for watching, guys.
Bye.